welcome to the world of mathematics. I am Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. Being an engineering student, you might be curious about why we are studying engineering mathematics. Mathematics is very useful in all engineering branches. It is useful in almost all subjects of engineering branches like programming for problem solving, basics of mechanical engineering, basics of civil engineering, control theory, network analysis, BE, basic electronics, and more subjects. So now let's move on to the introductory lecture of Mathematics 1. So this is the introduction to Mathematics 1. The whole syllabus of Mathematics 1 is divided into 6 units. Unit number 1 matrices, then after unit number 2 partial derivatives, unit number 3 sequence and series, unit number 4 Fourier series, unit number 5 indeterminate form and application of integrals, and unit number 6, that is multiple integrals. Now first of all we will see matrices. So first of all, what is the meaning of matrix? So matrix is a rectangular arrangement of elements arranged in rows and columns. Now matrix is divided into these topics. So we will study these topics in matrices, that is elementary row operations in matrix, then after row echelon form, reduced row echelon form, then after rank by echelon form, inverse by Gauss-Jordan, then after system solution of linear equation using Gaussian elimination and Gauss-Jordan method, then after eigenvalue and eigenvector, then after Cayley-Hamilton theorem, and finally diagonalization of matrix. Now these are some applications of matrices. The first one is image processing. So this is the restoration, then after blurring, then after brightness before and after. Then after we have second application of matrices, that is cryptography. With the help of cryptography we can encode and decode the message. Now we will move on to unit number 2, that is partial derivative. In single variable function we use ordinary derivatives, whereas in case of multivariable we use partial derivatives. So partial derivative, in this unit we will study these topics, that is function of several variables, limit, continuity and partial differentiation, then after chain rule, implicit differentiation and total derivatives, then after gradient and directional derivatives, then after tangent plane and normal line to the surface, local extreme values, and finally method of Lagrange multipliers. Now these are some applications of partial derivatives. First one is the graph of multivariable surface. This is the graph of a multivariable surface. Then after we have second application, that is maxima and minima. This is the example of maxima and minima. Then after we have third application, that is tangent plane. You can see tangent plane. Now we have unit 3, that is sequence and series. So first of all, what is sequence? Sequence is an arrangement of real numbers in ordered manner, and series is the sum of the elements of sequence. So in sequence and series we will study these topics, that is infinite sequences, convergence and divergence of sequences, convergence and divergence of an infinite series, integral test, comparison test, limit comparison test, ratio test, Rabi's test, root test, alternating series test, power series, then after Taylor series and Maclaurin series. Then after we have some applications of sequence and series. The first one is formation of sequence. So this is the example of formation of sequence. The second one is graph of Taylor series. So this is the graph of Taylor series. First one we have the graph of e raised to x, then after sin x. Now we will see unit number 4, and unit number 4 is Fourier series. So first of all, what is Fourier series? Fourier series is the sum of infinite terms of sine and cosine. We use Fourier series to analyze the periodic functions. It is very useful in signal and systems. Unit number 4, that is Fourier series, is divided into these topics, that is periodic function, Dirichlet's condition, Fourier series of 2 pi periodic function, Fourier series of a function of period 2L, Fourier series of even and odd functions, and finally half range Fourier series. Now we have some applications of Fourier series. The first one is formation of sawtooth wave. So this is the example of formation of sawtooth wave, how it is generated, that is in front of you. Then after we have second application, that is formation of square wave, and this is the example in front of you how square wave is generated. Then after we have unit number 5, and unit number 5, that is indeterminate form and application of integrals. So we have total 7 indeterminate forms, that is 0 by 0, infinite by infinite, infinite minus infinite, 0 into infinite, 1 raised to infinite, infinite raised to 0, and 0 raised to 0. So in this unit we will study about indeterminate forms, its limit using L'Hopital rule, some special functions like beta and gamma, and then after application of integrals. So this unit is divided into these topics, that is indeterminate form, L'Hopital rule, improper integrals, gamma function and its properties, beta functions and its properties, application of definite integrals, volume using cross section, shell method, washer method, volume of revolutions. So these are some applications. First one is volume by washer method. So this is the example of volume using washer method. Then after, the second application is volume by slicing. So this is the example of volume by slicing. Then after, we have third application, that is volume by shell method. So this is an example of volume by shell method. Now we will see the last unit, that is unit number 6, and unit number 6 is multiple integral. In multiple integral we will find out double integration and triple integration over a given region R. So the multiple integration is divided into these topics, that is double integrals over rectangles and general regions, change of order of integration, double integration in polar coordinates, triple integration in rectangular coordinates, area by double integration, multiple integration by substitution. Now we have some application of this unit. One is area. This is how we will find out the surface area. This is an example of surface area. Then after volume, this is the example of volume. Now we will see the weightage of mathematics 1. So this is the syllabus weightage. Unit number 1 is 15%, unit number 2 is 20%, unit 3 is 20%, unit 4 is 10%, unit 5 is 15%, and unit 6 is 20 percentage. Thank you for watching this video. I will see you in next lecture.